Hey everybody, it's Chris. Today I'm going to talk DevOps, developer and operations being sandwiched together like some delicious peanut butter and jelly sandwich. Now this is a world I've been in for too long. I think it's almost hard to remember the world before DevOps. There's been so many DevOps things forever. And this is inspired from different things I've seen on LinkedIn and conversations that I have where people like to talk about DevOps being dead or not dead. And for a long time, I thought it was dead, or at least the spirit of it was dead. But let's unfold that a bit. We'll start with some history. I've certainly been in this game since the late 90s and have seen a lot of the back and forth. But, you know, on the one side, you've got developers, software engineers, people that build code. And they certainly have the whip being cracked on them. There's this constant drive. There's never enough time. There's always a new feature or something that needs to get done. And typically developers are living sprint to sprint, which is a 2-week chunk of time, being asked to deliver more and more and more. And a lot of times they see when things like technical debt are being brought about or have opinions on what should happen to the code, but they're beholden to the business, to the product owner, to the engineering leader, whomever it may be. And so a lot of times they don't get to do exactly what they want to do. And kind of the same happens on the operations side of things. They traditionally were tasked with making sure that all of the things that ran developer code, the servers, the storage, the networking, were online, available, and really whatever the customer was expecting was happening. If they were expecting a 5 nines environment, meaning 99.999% of the time, they can go to the service and it would be up and at a nominal state, then that's the operator's job, is to make that happen, to provide backups, to make sure that everything is resilient, etc. Right? So make sure all of the stuff works to run the code. And this is where DevOps, I feel like, first entered my life, was because you have two entities that were at odds with one another, and traditionally, they were nowhere near each other. So development would be in its own little room or several rooms, because there's typically a lot of developers, and the operations team, which is almost always very small. It's usually several orders of magnitude smaller than a developer team, unless you're lucky, would have to be in their own area or remote or whatever it is, and they wouldn't talk to one another. So the idea was, if we bust these silos, these two different groups, we get them together, we get them to better understand one another, to work together, to realize there's a lot of common goals, then the things you see on your screen, such as better velocity, increased reliability, better ownership, etc., all these things would result in a better experience for the customer and all the ripple effects that go with that. Better experience for the developers, for the operators, but ultimately the customer would win, and therefore the business would win. Margins would go up, revenue would go up, customer retention would go up. Now, my first experience with this, and I wrote about it recently on the blog, and that's why I'm recording this podcast, because I want to take what I wrote on the blog and kind of add a voice track to it and give you some more context. Going back to my story, it was 2011. I had just gotten hired as a network operations manager. I had 2 people on my team, so 3 total if you include myself. And when I joined, it was kind of a mess. A good mess, though. A mess because it was a startup and it was small, and they started with one guy who did his best, and they were scrappy, but they'd grown to the point where they needed more. The main issue about what was going on there, what the challenges were that you had the siloing going on, but you also had things like no help desk system, no ticketing system. There wasn't really a good way to see the work, track the work, make sure the work was getting done, and hold those that should be doing the work accountable, right? That was the difficult part. And so I used lunch as a vehicle, as a tool to make sure that those silos were busted, that people were talking to one another, hearing the stories about what was going on in the dev environment, what release were they working on, like what pressure were they under, what commitments had our startup made to the customer, and then the kind of other side of that. Okay, because of that, things like having to do an SLA of 100% call recording, which is insane, what ops was having to do to supply that. The fact that we had 3 different call recording systems that all had to work in parallel, and that we had tape drives from Iron Mountain being shipped over every morning through Lockbox, and just our pain. And so because the pain was relatively shared now, we kind of understood the pressure development was under and the pressure that operations was under. A meal of cheap pizza, high quality cheap pizza, but this meal acted as the forcing function to break silos, and it gave a safe place for people to kind of bitch about what was going on, because we're there eating lunch. We're at work eating lunch. This was before really the whole work remote thing. Most people were in the office. I certainly was most of the time, and so that's why you'll hear a lot of like pizza stories like this, because I think it just was an easy way to broker peace over pizza. The other thing I want to pay attention to or highlight is that the way that software was really being released back then was that developers had their environment of dev, typically just dev, and dev was typically some old crappy server under someone's desk. Maybe there was a stage or a test, but most commonly there wasn't. There was just whatever they had to get the software working, and then toss instructions to operations, because developers don't have access to production, and then operations has to release that stuff and get it working in production. And we used runbooks. That was the thing that you traded in order to make that happen. And they weren't great. It was a lot of scripting. It was a lot of tribal knowledge, or I guess institutional knowledge is the more PC way to say that these days. And it didn't work very well. It would never work entirely. You'd always have to kind of fix it after the fact. On top of this, measurement was non-existent. Like, metrics didn't really exist. It was just get it across the line with burn marks all over your body. And if it's up and running and successful and things are green and working at a kind of up and down, think Nagios, think What's Up Gold level, you're good. And you're just moving on to the next thing, because it's probably Friday night or Saturday or Sunday. I certainly spent years of my life working Sunday through Friday with only Saturdays off, because Sunday was our deployment window, working through this. You didn't have time to like measure things. And so if you can't measure what's going on, if you don't really understand what's going on between the development process and then releasing it through these runbooks, you can't measure it, you can't manage it, you can't make it better. And that was another thing that we wanted to improve, was instead of having these really wonky runbooks, we wanted to make this process better. So that was another pillar of this whole DevOps thing. And I think up until around 2019, and I'm picking on the Enterprise DevOps Skills Report, I have a link there to the DevOps Institute website where I got it from. They highlighted a survey result where people said we want engineers and systems admins who can automate. That was the majority of what was looking to be done there, because the runbooks sucked. They were very manual. It was do these things and they always missed a step. It was understanding how software was released, so process skills, so that you can apply your systems thinking to these processes. It was soft skills, because a lot of it meant talking to other people, which traditionally was kind of avoided, right? I think a lot of people were actually lauded for never having to talk to people. Oh, that's Joe. He sits in his cubicle. No one talks to Joe. This man's a wizard, something like that, right? So soft skills, can you understand each other's environment and then talk to them without making them mad? And then all of your functional skills. Do you know IT? Do you understand networking? Do you understand kind of how it works from a technology perspective? And I think at the time, up until this point, this was a reasonable list of things to expect a human being to be able to do, right? You didn't have this giant ecosystem of tools to know. It was way more about the software. It was way less about all the services that could potentially run the software. It was almost entirely on-prem, because we didn't even really get cloud until 2008. And it didn't become super popular until the mid-2010s, right? 2012 to 2015, you really started to see traction for cloud for more of your mainstay folks. And so that's why I think it's important to remember we weren't expecting unicorns Full stack engineering wasn't a term yet. Platform engineering and infrastructure engineering. We just wanted systems administrators and infrastructure people who could work with the development process. And that only lasted for a period of time. And I think a lot of companies never even really got to enjoy that, because by the time they really realized about this whole DevOps thing, the fact that it was a great way to do things, a great way to organize and motivate and energize your people and get code out the door that your customers would be delighted by, the thing that I have at the bottom of this slide, the complexity and scale of how we build software and more importantly, I guess, run and manage and measure software, changed so dramatically. So we're going from knowing things like version control, using Jenkins, using Git, using maybe some Docker. In a lot of cases, we were just running Linux servers. Configuration management was entering the scene. There's a lot of Puppet versus Chef, Ansible for your networking nerds, right? I guess what I'm trying to say is there wasn't a lot of choices here. It was pretty early days. APIs were not ubiquitous. And so you were working with these proprietary systems and mainframes and kind of heavy on-prem platforms. This changed, though, from 2019 and beyond. It really significantly changed because cloud native had been a thing for a while, but then it really became mainstay. Partially, I think, because the big boys were doing it. You couldn't turn a corner without hearing about Netflix or what Amazon was doing or whomever. And people wanted to emulate that, but they never took a moment to look at what they had, both from a what software have we deployed, a process perspective to see how we're doing business, how we're releasing software, and the skills of your teams. But we still changed system complexity. We made things really difficult. We moved I feel like a lot of people just jumped directly into cloud, pass go, collect $200, never did any of the refactoring for their people, process, or technologies. And that's why we had so many folks that were in the cloud going, this is horrible. This is incredibly expensive. Because we just tried to skip ahead without doing the work. So I have here on this slide, we're moving from these traditional monolithic applications. We used to just think of them as applications. You put them all on a server. Maybe you virtualized it with VMware, right? But VMware didn't really change the game in terms of what we were doing. It just changed the games in terms of capacity planning and capacity management. When these cloud native architectures came out, yeah, they became core very quickly, but they challenged everything we kind of built up to that point, including hypervisors and virtualization, right? That model didn't really work very well, but that's where everyone was going because you could save 90+% on your data center costs, on your depreciating costs. You have to buy less things to run stuff. So as we move towards these cloud native architectures, or at least some people did, yeah, we get scalability and resilience and this global sort of virtual data center that's being run by these cloud providers. But we also get dramatically more complex systems, dramatically, to the point where no one really knows how it all works anymore, which is kind of to our detriment, I think. I think when things get that level of complexity, they start to lose coherence with those that have to build and run them. There were other things that happened during the time of 2019 plus COVID, of course, but talking more technology, things that I think infrastructure engineers and people that were trying to be on the ops side had to learn, such as Terraform and infrastructure as code in general, became table stakes really quickly. You didn't have a lot of time to kind of mature on that. Automation went from these basic scripts to Jenkins to GitHub and GitLab, and all of a sudden everything was being put in the pipeline, whereas originally pipelines were just kind of like build servers. Security entered the scene. It went from something that was relatively straightforward to protect to something that was kind of spread against the spaghetti of the cloud, and trying to plug all that stuff was difficult, and we didn't have new models, right? We were still trying to apply kind of perimeter defenses to something that was more ephemeral. And frankly, I feel like a lot of infrastructure folks had just sort of gotten the idea behind automation and infrastructure as code, and then were told, hey, you need to start learning software development. So big jump. a lot of things to have to learn in a very short period of time. And at the same time, it was on top of quicksand because all of the services in the platform at that cloud native level were changing so rapidly that it was just difficult to keep up with the infrastructure or what's on top of it. And so now I think back to some of the projects I've been responsible for over the past 5 or 6 years. And I just threw a couple examples on this list here, like, hey, not only building these kind of straightforward pipelines, but like designing, building, maintaining them, having to deal with nuances like caching and parallelism, and how do we handle these very large dev teams that are all trying to merge code at the same time? Yes, we're managing infrastructure as code, but we're implementing it maybe in multiple different languages. Hey, we have to offer a CDK and Pulumi and Terraform and who else knows what, right? And the list goes on and on. And that's a challenge, right? Trying to know those things at any level of depth and then surrounding a team and a set of processes and tools around this is tough. And it takes several attempts at doing it before you get good at it. And even then, good at it is kind of a relative term because you're never really going to see the same type of application twice because our application models just blossomed. It's funny to me that forever it was like the monolith is bad, and then we broke the monolith and made it microservices, or at least services that are talking to one another. And now I hear about mini monoliths and other, it's just crazy, right? So we're constantly kind of moving around the shape of what we're trying to build. It's like, yeah, we're still using eggs in our breakfast, but someone wants an omelet, someone wants them scrambled, someone wants them, over easy, whatever. It's difficult to know the 100 different ways to make eggs. That's why chefs get the hat with all the pleats in it. I also feel like there's a deeper layer to this because what I'm seeing now in this sort of modern world is we don't really want an infrastructure engineer. We want a software developer that knows infrastructure. And those tend to be oil and water. It's not super common to find folks that really understand the software lifecycle that also deeply understand the infrastructure side of things. It's difficult to know that much stuff. I've always been an infrastructure person. Systems administrator is kind of how I identify more broadly, that liked the idea behind software development and wanted to borrow a lot of their methodologies, their processes, their tools, the way they communicate. I wanted to borrow all that and use it for infrastructure and platform and systems. But now we're looking for people that substantially understand software development and software engineering to the point where they can also write code. Probably not at the same level. That's pretty uncommon, but if you don't understand things at that level, it's going to be really challenging to provide all of the supporting structures that go with that software. A couple years back, I did a presentation on work that I did for a state government that needed a new platform in GovCloud. I've talked about it on different podcasts and different presentations, but this is an example of kind of what was being expected for people that worked on the platform to supply the application a home. And it starts with understanding the application architecture. You can't just know Terraform and AWS constructs. You have to understand APIs and their methods and how to secure them and how to monitor them and rate limiting and paging and versions and all of that stuff on top of platform architecture, deep networking at a global, regional, and local level, being able to supply opinions on how to structure the branches in the code, the release strategy, because you're typically in charge of those rules and the RBAC that goes with what's going to happen with your source code and how it gets released and how it gets in the production environment. Another one I'll highlight is in the middle, I have building sandboxes and test beds, and that's like the bulk of the work because the developers need pre-merge and post-merge feedback on what they're building, not only for what they have, which they can run stuff locally, sure, they can run unit tests and things like that locally, but often in integration with other people, right? So the dev environment is now becoming way more complex than it originally was because we have to see my change pre-merge, your change pre-merge, all of our changes together post-merge, make sure all of that looks good, bundle it up, make sure that gets to the next environment at the right cadence. There's quality engineers involved. It's very complex. And at the bottom, I have cost controls, right? Because you're always going to be challenged by the application team to provide the tier 1 service. Everyone wants their own private database, as an example, in AWS. But who's going to pay for that? That's incredibly expensive to do. You're going to often have to share these resources. And so you're on the hook for shared services, platform services, more domain and product specific services, kind of everything in between. And I just think that's incredibly difficult, requires a lot of context switching. So in summary, we started this path because we wanted to change the culture between dev and operations. We wanted to make it so that they worked together and understood each other and were driving towards a similar outcome. It made sense. And then now we've evolved into this hyper sophisticated discipline for managing kind of everything inside of a cloud native environment that I've showed you earlier. And that's a big change. And that's not something I think everybody's really grokking. And I'm not even adding AI to the list yet, right? That just makes it even more messy and sloppy depending on how much you think about AI. So food for thought, if you're wanting to maintain a place in this arena, if you want to be a DevOps engineer, or platform engineer, or infrastructure engineer, pick the flavor of ice cream that you want to call it. You're still working with software developers to make sure what they release is done in a performant, reliable, secure manner. You're going to have to take this journey too. I'm sorry to say, it no longer is enough to know the infrastructure. You're going to have to get into this cloud native software world because that's what people are hiring for. And frankly, it's what people are looking for. My opinion on that. Food for thought. Curious, what's your opinion? Have you been in a similar boat? Do you disagree and think that we're going in a different direction, or your experience has been different from mine? Let me know, because I think it's about to get super wild, if it's not already, and hold on to your butts, because it's about to get ultra crazy in the world of DevOps and platform and whatnot. So with that, thank you so much for joining me. I look forward to seeing you on a future episode of the podcast. Let's talk again soon. Peace and love.